How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at the solution process and saturated solutions and solubility practice problems. All right, so number one, what prevents octane from dissolving in water? Well, first, hopefully you can look at octane and go, hey, that is a nonpolar molecule, which means it has London dispersion attractive forces, whereas water is polar and it has hydrogen bonding as attractive forces. And we remember that like dissolves like. So these things have different attractive forces, so they're not going to want to mix in together. They won't dissolve together. So which one of these options shows that? Well, let's see. The dipole-dipole attraction between octane molecules, that's not what octane has. The London dispersion forces between octane molecules, they're not super strong compared to like other intermolecular attractive forces, so that's not why they won't mix. But the hydrogen bonding between water is really strong. So the water molecules are going to keep hanging out together instead of mixing with the nonpolar octane. Let's see the rest of them. The ion dipole attraction between water and octane? No, there's no ions, so it definitely can't have ion dipole. And the repulsion between like-charged water and octane molecules. No, that's just kind of a good nonsensical answer. All right, number two, what is meant by the phrase like dissolves like? Again, they're talking about the attractive forces. So if they have similar attractive forces, they will dissolve. Let's see what we got. Solvents can only dissolve solutes of similar, so close. Molar mass is not the word we want. Gases can only dissolve other gases. That's not what we're talking about. Polar solvents will dissolve, non-polar solutes. No. Condensed phases can only dissolve other condensed phases. No. Polar solvents dissolve polar solutes, and nonpolar solvents dissolve nonpolar solutes. Yes, thank you. All right, number three. Some solution processes can be endothermic, but still occur spontaneously. This is because why? So normally, nature favors losing energy or exothermic processes, but we can still have endothermic processes that occur spontaneously. Look at those ice packs where you got to break them and then they instantly get cold. How's that going on? The reason that they occur still is because there's an increase in disorder or entropy, right? So even though it's endothermic, which is unfavored, the things getting messier and increasing in disorder is favored. So that kind of wins that battle. 4, which describes a saturated solution. I'm just going to jump the gun. I'm going to tell you that it's B. All right. It contains dissolved solute in equilibrium with undissolved solute. So you have both processes going on. You have, let's say, a cup here, and it's filled with water, and you got some solid on the bottom, and some of it is dissolving, but it's occurring at the same rate that the dissolved is precipitating. So it's in equilibrium. All right. So I hope you found that helpful. See you in class. Goodbye.